Now, when Greg is done here in about 10 minutes or so, we're going to take a break. For folks in the audience, we're going to adjust our schedule some and maybe move one of the topics like Nikki's off in the afternoon is kind of the plan for here. So, yeah. Looks like Greg is ready to go.
All right, sorry, yeah, I guess we're running a little late. I apologize for that. Okay, so in terms of one of these ideas of what kind of short-term management strategies can we provide growers basically to try to deal with this crisis, one of the issues we want to look at and have been looking at is, can we enhance efficacy some of the insecticides that we have labeled for the crops in our area by adding adjuvants, particularly sugar and yeast. And this is something that has been done with other pests. And one of the reasons we were interested in doing that is we do have actually quite a few insecticides that we potentially could use against spotted-winged Drosophila. This is a figure I bet you've seen before that Rufus Isaacs kind of put together by polling a bunch of us researchers on the results of their insecticide efficacy trials on spotted wing against a number of different compounds and ranking them from excellent to not very good. And I hope you can see the slide okay. I just got listed a bunch of different compounds on the x-axis. And you can see kind of there's a few of them that are actually considered excellent to good, and then a lot of them that are just fair. And really the question we're getting at is, could we convert some of these compounds that were considered fair into good or even excellent by adding some adjuvant to this to enhance its toxicity? A good example I'll talk about is assail, the neonicotinoid assail. In a lot of trials, our trials included, if we apply that, we really consider it only a kind of fair in its efficacy. We like it in some other ways, so it's one we'd like to use as a rotation partner in a kind of a full program, but it's not considered particularly good. So can we improve that upon that? Another one might be, let's see, where is it in here? Entrust, the organic version of the spinosans. Again, considered fair to good, can we make it, improve it to excellent? And the idea behind these is the following, which you're probably all aware of, is that flies, when they detect a sugar, or some salts in fact, have sort of an automatic instinctual response to feed. And if we add sugar, for example, to an insecticide, if they contact it with their sensory system in their feet, will they reach down and eat that material, ingesting an insecticide, hopefully increasing their exposure to insecticide. My colleague Rich Cowles has some nice lab data kind of demonstrating this, looking at the LD50 for this insecticide assail, acetaminophen, at increasing concentrations with and without a small concentration of sugar, quite a low concentration of, I think it's now, I'm forgetting what percent, but it's quite a low rate of kind of the equivalent of about 2 pounds per 100 gallons. And what you see is a shift in this LD mortality curve in response to the addition of sugar, so that you go from an LD50 of 82 parts per million to 41. So potentially this could lead to some improvements in the field. The idea of using yeast is sort of twofold. As I've indicated, adults readily feed on fermentation products that include yeast and have alcohol in there and other products, and the yeast themselves provide a protein source. And if we rear females with only sugar, they don't produce many eggs. And if you give them kind of a fermentation yeasty product, they produce a lot of eggs. So suggesting that the flies ought to be kind of responsive to the availability of yeast or yeast plus sugar. In addition, we know that sugar in itself is not attractive at a distance. So you can't really put sugar out and get them flies to find it or increase their chance to find it. But yeast and the yeast products through kind of fermentation are the basis of a number of these lures. For example, the Century lure and also the Tracy lure is based on these 4 components that my colleague Don Claw identified coming from fermentation products of wine and vinegar. that include acetic acid, ethanol, acetone, and methanol. And just in this data, you see that we see nice increases or relatively the same trap catches with this synthetic blend as we do with wine and vinegar. So this is a question that several of us have started to look at for spotted wing Drosophila. This table kind of summarizes some of the work. Some of the work has been done primarily in the lab. Some has been done both in the lab and the field. Rick Bowles, again, my colleague at Kinetic Experience, I worked with, as well as Cesar Sauna Rodriguez at Rutgers. And we looked at this both in the lab and the field with multiple classes of insecticides focused on low concentrations of sugar. And I will kind of summarize a little bit of that data for you today. Some Italian workers, actually in collaboration with Washington State, have been looking at this question with spinosad only, the things like Delegate, etc., spinosad type products, and looked at the effects of yeast. And in this case, a particular yeast is so often associated with spotted wing. Alan Knight out in Washington State has been also doing work with yeast, in some cases combination with sugar, and its effect on the insecticide Alticor. No, I'm sorry, this is not Alticor, it's Exerol. Okay, so just to give you a little bit of data, and I'll focus more on the field data. I think in some ways that's the most relevant. I don't have a strong take-home message here, but the pattern seems to be consistent, at least with sugar, that we're providing a little bit of a boost on some insecticides. Now, this is an experiment we did in day-neutral strawberries in Geneva, and here we compared Entrust with and without sugar once a week with just a sucrose plus water control and a water control. I think it's important to have those control treatments in these experiments to test for the independent effect of the sucrose, which could have either a negative or a positive effect on the flies. And we compared that with a weekly or even a twice weekly application of this pyrethroid brigade. And we assessed eggs per fruit out of this field kind of on a weekly basis. We also looked at things like fruit rot, and we reared flies out. Just a little bit of the data, the other data kind of supports this. This is multiple weeks of information on emerged flies collected from the field and brought into the lab and reared out for the control treatments here of sucrose or water only versus Entrust plus sugar brigade. And overall, the pattern shows that, and I want to focus here on Entrust plus sugar. From field data, for most of the weeks, we got a slight decrease in emergence of flies associated with adding a little bit of sugar with the Entrust at 2 pounds per 100 gallons concentration. That 1 week, I can't explain this. We had a lot of infestation in the Entrust plus sugar. I don't know if it was an issue with contamination. We messed up our samples, but it didn't make much sense to me, so I'm sort of left in the dark trying to explain it. But overall, we see a slight 10% benefit. And it was actually, except for this 1 week, comparable to weekly or biweekly brigade treatments, which is considered a quite excellent material. Now, fall raspberries or day-neutral raspberries in the later summer are perhaps not as susceptible a crop as others, so this may be not the most susceptible, but it did indicate some benefits based on field results. The next slide is some information that I got from Cesar Rodriguez Sauna at Rutgers. I'm going to say this last time I mentioned it. On blueberries, again, in this case, a field trial where he compared a sort of a program of a delegate and a sale, spinosad and the neonicotinoid without sugar compared to sugar, and compared it to no spray at all on blueberries done in the field. And what he found was that there was, again, an indication of some benefits in terms of adult spotted wing reared from fruit when adding a little bit of sugar to these sprays. And granted, delegate's actually considered a pretty good material, and a sale would be considered a fair material. So kind of a reduced risk program in blueberries, and they're showing some benefit to sugar. So those are the results that we've got from sugar, and I think some of the other studies have supported this to some extent, that there is some benefits to adding sugar to some classes of insecticides, not necessarily all of them. Although in the research that Rich Cowles did, at least the lab and some of the semi-lab data suggested several different classes of insecticides did have improved efficacy when added to sugar, including a pyrethroid, which we didn't actually expect, but also including some of the other materials that need to have consumption or ingestion to be effective, like a sale or exerol. Okay, so the question of yeast, I mentioned that a few studies had found, at least especially in the lab, that yeast alone had improved efficacy of some insecticides, although they typically didn't include a yeast control in that experiment, a yeast-only control. And then a couple of results, or at least one result in the field, where at least yeast plus sugar actually had some improvement, and this was in cherries. This is the work by Alan Knight. So we wanted to look at this, and this is part of our SCRI project that Rufus is working on, Rufus Isaacs, and also Ash Cial down in Georgia, where, and we're doing this in fall raspberry, Rufus is doing it in blueberries as well as Ash. So the experiment we did this year, and we still haven't fully evaluated the results, but we wanted to compare sort of the full factorial treatments using delegate as our toxicant and doing it in combination with sugar, or delegate with yeast, or delegate plus sugar plus yeast in a susceptible crop. And then we included a water control, a yeast only mixed with water at the same rate used in the delegate, or sugar alone, or a combination of yeast and sugar. Again, trying to be able to account for the effects of these adjuvants on their own. Our assessments involve both field infestation measurements and something I mentioned before, semi-field bioassays. And what these are is we do the sprays outdoors, and then, at least for this experiment, in 1 week, we collected fruit and some leaves, brought them into the lab, and put them in containers, and then added adult spotted wing, 5 males and 5 females, from our lab colony. This is actually a protocol developed at Michigan State, and we followed it pretty much to the T. And we did this the day of spray. We did this 3 days after, and we did it, I think 5 days after, and we might have actually done 7 days after. And then followed the survivorship of those adults, and after 7 days, what their reproduction is. So it's actually quite a large experiment. We're still trying to sort through that part of the data, but I want to show you a little bit. So from the infestation data, sort of the field plots, and these weren't large plots. They were about 8, maybe 7 meters long, about 20 feet long. They were not particularly large. We got this kind of average response over about a 3-week period, where I'm plotting the number of flies per gram fruit reared out of this fruit for our different treatments. And based on field experiments, what we see is that the delegate plus sugar, in terms of the numerical value, had the least amount of infestation, followed by, again, delegate sugar yeast and delegate alone, and delegate yeast. And then the controls were all roughly above that in terms of numerical. But we didn't get big effects, and statistically speaking, I think we had five replications per treatment. Really, we only get a little bit of statistical significance, as you can see from the letters. So in magnitude-wise, we get maybe again that sort of between delegate and delegate plus sugar, that 15% decrease in infestation. It's not insignificant. Well, in this case, it is insignificant, but I think it's not, because we see this in other experiments. I believe there is some, legitimate benefit with delegate anyhow, and a sale in improving their efficacy, but it's not a large magnitude effect. As I said, we did this in the lab as well, and I'm just now digging into the data. I wanted to show you one result. So this is a result from fruit and leaves collected right after spray, so 0 days after treatment, where we put in these flies and let them kind of feed and reproduce, and then we measured This is just the data on reproduction, which should reflect both survivorship of the adults and reproduction. And really what comes out of this is Delegate was pretty effective, as you know, after the, you know, when the flies were exposed immediately after spray. We get some indication in here that sugar had some sort of deleterious effect on reproduction overall. Yeah, I'm not sure what to make of this. I really need to dig into this data more thoroughly. And whereas yeast and sugar plus yeast, we didn't see as much of that, but a little bit. So, you know, we're still scratching our head on that. So I guess I just wanted to show you we did this, but I think I'm not going to try to derive any really big conclusions yet from this what I call semi-assay results. It's good to see, though, the Delegate was effective after 0 days. Okay, one last thing on these results, and I can wrap it up here. One of the questions we often get in adding sugar, even at these low concentrations, what are some of the non-target effects of either sugar or yeast on things like natural enemies or pollinators? This is something I think we want to be able to look at, and particularly for crops like fall raspberry, where we have things flowering at the same time we have ripe fruit. But more broadly, you know, it's important to have some sense of how these things might affect natural enemies or pollinators in a cropping system. Are they attracted to the sugars or sugars plus yeast, or at least feeding on it, increasing their toxicity? And we're just now beginning to do that. One of the things we did this summer is right after spraying our raspberries, we went out and measured visitation of pollinators, and in particular in our system it was mainly bumblebees and a couple different species of solid on flowers in these different plots. And overall, we just didn't see any sort of effect on least visitation rates from this spray that occurred just a few hours previously. So that, I guess that's good news, but I do think it's kind of early days in terms of assessing this question for both pollinators and natural enemies. It's a low concentration, so you know, I guess I'm hopeful that we're not going to see a big effect on these non-targets. Another question we often get is does sugar in the spray kind of cause an increase in fungi or fungal diseases? And we're not seeing that at this point. We don't see a lot of sooty mold develop on it like you might see if you had an aphid infestation, for example. In our experiment with day-neutral strawberries, we didn't see an increase in things like, you know, fruit rots associated with the sugar additions. But again, it's something we ought to be looking at as we move forward. In terms of recommendations, we are saying, you know, to growers in New York that, yeah, this is legal to do. Add the sugar as an adjuvant that may provide some benefits, and so far we're not seeing negative things. I'm really not sure what to say about the yeast. In our circumstance, we didn't see a big effect. I will mention that in our planting, I'm sure we had a ton of yeast out there already. It's unclear to me that adding a little bit of yeast in our spray made it any different. But I could imagine in some circumstances that are getting a lot of fungicides, for example, in sprays, that maybe yeasts are low, and adding yeast plus sugar anyhow might provide some benefits that we need to look at. Okay. Again, I want to thank my lab and collaborators. Particularly, I want to thank Steve Hessler, as research support specialist in my lab, who really kind of ran this efficacy trial for this year. And with that, I can again see if there's any questions.
Questions from the group? How about Emily? Any questions on the Zoom? All right. How about a nice round of applause for Greg joining us via Zoom is a little bit of a challenge, and then Greg, we hope that your wife is okay, and we know that you need to probably